Hello, welcome to Apex Math. Today we're going to do a lesson on advanced factoring methods. So let's talk about what those are. We are going to look at difference of perfect squares, difference of cubes, sum of cubes, remind you how to do simple factoring, and when it's done, bottoms up factoring, factor by grouping, and one other method that I refer to as let x equal something method. And of course we always have the GCF as part of factoring as well. So we are going to use all of these different methods. And the first thing you need to do is to be able to distinguish when do I use which type of method. So that's the first thing that we're going to look at. So the GCF, which is your greatest common factor, which is when you have something in common with both terms, that has to be used with every factoring method if there is a term that needs to be factored out. So this GCF method is going to go hand in hand with all the factoring methods that we use. It may or may not come into play, depends on the problem. In this particular example that I gave you here, this would be just a GCF problem. You can see here that if we look at the numbers, both numbers have a factor of 2 in common, and then if we look at the variables, both have an x in common. So we would factor out a 2 and an x, and then see what was left over. If we take a 2 and an x out of 2x squared, it leaves us with just x. And if we take a 2 and an x out of 4x, it leaves us with 2. So this would be the GCF, and we factored that out, leaving us with x plus 2, and that would be in factored form. All right, so let's look at what happens when we see two terms. When you see two terms, there are 3 different possibilities that you can have for factoring. There's always the GCF, so that's always in addition to these 3. That may be by itself or in addition to one of these 3 that I'm going to give you. So the first is difference of perfect squares. And difference of squares is the form a squared minus b squared, and the formula for that is it factors into a minus b times a plus b. So what you're looking for here is that there's 2 terms. You can see here's a term and here's a term, that there's a minus between the 2, that's where the word difference comes into play, and that the 2 terms themselves are perfect squares, that you can take the square root of them and get back a perfect number, like 25 is a perfect square, or an even power of a variable like x to the 6th is a perfect square. So an example might be 25 x squared minus 36 y to the 4th. So you can see that this meets our criteria. There's 2 terms, 1, 2. There's a minus between them, and each of these is perfect squares. If I take the square root of this, Square root of 25 is 5, and the square root of x squared is x. And if I take the square root of this, the square root of 36 is 6, and the square root of y to the 4th is y squared. The square root of any even power, you take half of it. So it's going to factor into, you take the two square roots and you stick a minus between them, and then you repeat it and you stick a plus between them. Now you should have learned this in your first level algebra class. This should not be new. The new one is going to be when we introduce difference of cubes and sum of cubes. But now we're going to be looking for difference of squares among difference of cubes and sum of cubes. So let's look at our second example. So our second example, again, this is when we have two terms. And remember, the GCF may have to be factored out first if it's there. And this is going to be difference of cubes. So this is when we're going to see something to the third power, and it's different, so it's minus something else to the third power. So that is going to factor into taking the cube root of each of these, so you get a minus b, and then you're going to have that value that you took the cube root of, you're going to square that value. Then you're going to multiply these two terms together, a, b, and then you are going to square that second value. So that's what it factors into. So let's do an example here of, say, 64 x cubed minus 1. So again, we notice that there's two terms. So we're going to go look under our two-term type of factoring. We're going to see if there's any GCF to factor out. There isn't. And we're going to see that it's a difference. So it's either going to be difference of squares or difference of cubes. And 64 is a perfect square, so it could be difference of squared. But x cubed is not even. So it's going to have to be a cube and not a square. So what is the cube root of 64 x to the third? That is going to be the value of a. So what times itself 3 times is equal to 64? Well, if we have 4 times 4, we get 16. And then 16 times 4 is 64. So we end up with 4, and the cube root of x to the third is just x. So our a term is going to be 4x. B is going to be the cube root of 1. And that's easy because that's just 1. Now, the other pieces we need to use the formula is we need a squared. So now we're going to go up here and we're going to square a. So we're going to take a, 4x, and we're going to square it. So 4 squared is 16, and x squared is x squared. And we're going to take b, and we're going to square it. 1 squared is 1. And then the last thing we're going to do is we're going to multiply a times b. So we're going to do 4x times 1. And that gives us 4x. Now we can plug it into our formula, now that we've found each of the individual pieces. And I recommend writing out each of the pieces. It makes the problem much easier to do. So we're going to have a minus b, so that's 4x minus 1 times a squared, 16x squared, plus ab, which is down here, 4x, plus b squared, which is 1. So this is what that factors into, what 64x to the third minus 1 factors into. All right, let's go on to our next example. We're still looking at two terms, and now we always need to still consider the GCF, but now we want the sum of cubes. Now notice there is no sum of squares, okay? So for sum of squares, if you see something like x squared plus 9, you cannot factor that. We call that prime. It's not factorable. So there's no sum of squares, but there is a sum of cubes. So if I have a cubed plus b cubed, that's going to factor into a plus b times a squared minus ab plus b squared. So same formula, the only thing that's different are these two signs switch places from where they were with the minus formula. But otherwise the formula is the same. All right, so let's look at an example. It would be very similar to what we had before. Let's say we have 8r cubed plus 64. So we want to do the cube root of each of these to find out our a. So we want the cube root of 8r cubed. So that's our a. So the cube root of 8 is 2, and the cube root of r cubed is r. To find our b, we're going to do the cube root of 64, and we already said that that was 4. Now we're going to do a squared, so we're going to square 2r, so that's 4r squared. Now we're going to do b squared, that's 4 squared, which is 16. And now we're going to do a times b, so that's 2r times 4, which is 8r. And now we're going to plug it into that equation, which remember was a plus b times a squared minus ab plus b squared. So if we just plug it in here, our a is 2r plus b is 4 times a squared, 4r squared, minus ab, 8r, plus b squared, 16. So that is what it factors into. All right. So that is how we handle all the possibilities when we see two terms. So what happens when we see three terms? When we see three terms, remember, we're still going to look for that GCF. It may be there to factor out first. We may run into simple factoring. And by simple factoring, I just mean the factoring that you did back in Algebra 1 when your coefficient of your lead term here was 1. 1x squared plus 5x plus 6. Something like that. And you know how to factor that. A second example is where you would use bottoms up, and we have a video on how to do that. So bottoms up factoring, and that is used when your leading coefficient is not 1. Something like 2x squared minus 13x plus 20. So three terms, but this leading coefficient is not 1, so you have a couple extra steps. In bottoms up, you multiply your first term times your last term, you get 40, think of two things that multiply together to give you 40, but add together to give you 13. So we have, let's see, 4 and 10 would give us 14, so that's not going to work. 2 and 20, that's not going to work. 8 and 5, oh, that one works. 8 and 5 will give us 13. So we have 8 and 5. If I make them both negative, I will get a negative 13 and a positive 40. Now, since I divided by 2, since I multiplied by 2 in the beginning, now I'm going to divide by 2. So I'm going to divide each of these by 2. Let me go ahead and just erase some up here. And so I have negative 8 over 2 and negative 5 over 2. So now I'm going to reduce, put these in simplest form. This reduces down to negative 4 over 1, and the negative 5 over 2 doesn't reduce. And I reduce them so that I leave them still as fractions, even though it reduces down. Then I do bottoms up, which is where I put the x with the bottom number, and I do the bottom first, and then minus or plus the top, depending on what the sign is up here. So 1x, and then the top minus 4, and 2x, and then the top minus 5. And that's the factored form of this guy right here. And there's more examples of that if you watch our factoring video on bottoms up factoring. All right, so that is our second possibility for factoring when you see 3 terms. Now the third possibility is when you see something like this. 2x to the 4th plus x squared minus 6. Now there's still 3 terms, 1, 2, 3, but the power on your first term is not a squared power. So what you're going to do is you're going to look here and you're going to say, well, if I let x equal x squared, I can make this problem look like the type of problems that I'm used to factoring. So this x squared becomes an x, and the x to the 4th jumps down to an x squared, because x squared squared is x to the 4th. So this then becomes this equation. So all I've done is replaced my x squareds here with an x. Now I can do regular factoring that I would do depending on what type of problem it is. It's a bottoms up. So I'm going to multiply these 2 terms together, and I'm going to get negative 12. And then I'm going to think of 2 numbers that multiply together to give me negative 12, but add together to give me 1. First thing that comes to mind there are 3 and 4. So I want since I want a positive 1, I'm on a negative 3 and a positive 4. Since it was bottoms up, I have to then divide by that leading coefficient. And now I'm going to reduce these. So I have negative 3 over 2. That one's not going to change. But 4 over 2 is going to change to 2 over 1 if I reduce it. Now I'm going to do my bottoms up. I'm going to stick my x's down here. And this would factor into 2x minus 3 times 1x, or just x, plus 2. But I'm not done, because I made this substitution in the beginning. Now I have to substitute it back. So wherever there's an x, I now have to put in an x squared. So here's an x, so I'm going to turn it into an x squared. And here's an x, so I'm going to turn it into an x squared. And now I look at what I have left and see, can I factor 2x squared minus 3? Well, it's a difference problem, and it's 2 terms. So if I have 2 terms, I know I'm going to look for difference of perfect squares or difference of perfect cubes. It is not either of those cases, so I cannot factor this. Then I'm going to look at this one. It is also two terms. So I look at my two-term possibilities. Difference, it's a sum problem, so the only possibility I have for factoring here is sum of cubes. It's not a cube because it's x squared. So therefore, this cannot be factored any further, and I am done. However, a lot of these you're going to find can be factored further at this step. And once you get to this step, that you're going to have to factor further, and that you will not be done once you put those squareds back on. All right, so let's continue on here. And let's look at the last type. And the last type is when you see four terms. When you see four terms, that tells you you want to use the approach factor by grouping. And so here's an example of that. X to the third minus 5x squared minus x plus 5. All right, so for this problem, I'm going to use factor by grouping because it's four terms, and that's the only strategy I have for four terms. I'm going to make sure that the two things that are on this side and the two things on this side, that they have something in common that I can factor out. Sometimes it takes me a step to make sure that they're there, but if I look here and I see that this term and this term have an x squared in common. So this is my line, and right now I'm pretending that this over here doesn't even exist. I'm just ignoring that, and I am factoring x to the third minus 5x squared, factoring out a GCF. So I factor the GCF out, it's x squared, and that leaves me with x minus 5. Now I'm going to pretend that this side doesn't exist, and I'm going to come over here. And I know that I want my factor over here to have an x minus 5 in it. So what can I do to this over here so that one of my factors is x minus 5? Well, since there's not much to factor out here, I really only have the choice of factoring out a 1 or a negative 1. If I factor out a 1, then I'm going to be left with what we have here. If I factor out a negative 1, then it switches both signs, and that gives me the x minus 5, which is what I'm looking for. So you always want to make sure that when you divide this, that each side ends up with a factor in common. Now you have that factor in common, so now you're going to take the factor that they both have in common here, and that's going to get removed or factored out. So I'm going to take that out, x minus 5, and I'm going to write what's left. What's left is an x squared here and a minus 1 here. So they're going to get put together into another factor. But again, whenever you finish these advanced factoring problems, you always want to ask yourself, am I done? So I go and I look at this. It's two terms. Two terms means that I'm looking for difference of squares, sum of squares, or sum of cubes, or difference of cubes. So those are the three things that I need to look for when I see two terms left. This problem here, x minus 5, fits none of those descriptions, so I don't have to do anything with him. So I move over to this guy. I see an x squared. That makes me think of squares. I see a minus. That makes me think of difference. And 1 always fits all three of these. It can be a square or a cube. So this is a difference of squares. So I can factor him further. So I am going to factor this guy as x minus 1, x plus 1. So that means my entire answer is x plus 5, x minus 1, x plus 1. Many times in these advanced factoring problems, the hardest part is making sure you go far enough. Making sure that when you look at your final answer, you don't see anything left that you still need to factor. Always go through and remember what to look for in each of the different scenarios. So remember, anytime you see two terms, you are going to look for sum of cubes, difference of cubes, or difference of squares. If you see three terms, you are going to look for simple factoring, advanced factoring, or the bottoms up, and the let x equal if it's a higher power. If you have four terms, you are going to look for factor by grouping. And when you finish one set of factoring, go back and look at your answer and reevaluate it. Is it a two-term? Is it a three-term? Probably not going to be that. But if it's one of these two terms or three-term answers, does it then fit one of these remaining criteria that you can evaluate further and factor further? All right, if you would like to watch, we will do some extra examples in another video for advanced factoring, just to do some harder ones. So check that out. And thank you for visiting Apex Math. I hope we were able to organize this for you. Check out our website, as we will put the study notes on the website, where it reviews for you what to look for in each of the different cases when you're doing advanced factoring.